All right, good morning. Today we're going to talk about electrical charge and static electricity. This is PS11, which is A, which is static electricity. So our essential question, our big question we want to ask for this section is, what makes something electrically charged? So as you already did, is on your group's chart paper and on your paper, you're going to write, what are some uses of electricity? We answered, how does electricity get to our homes, schools, and other buildings? And I wanted you guys to describe some characteristics of magnets. So these are some questions we talked about earlier before you guys did this video. So, and then we also discussed this. Electrons have a negative charge. Did you think that was true or false? Objects with like charges attract each other. Did you think that was true or false? Copper is an electrical conductor. Did you think that was true or false? And objects must be touching to exert electric force on each other. True or false? So hopefully by the time you're done with this video, you'll be able to answer all these questions. As we did earlier, we wanted to observe some static electricity. So we took the balloon, the old balloon trick, and we rubbed it with a cloth or rubbed it in our hair or whatever. And if you slowly move it towards your hair, you actually see the balloon attracts the hair because the balloon has a negative, electrons, and the hair has more positive electrons, and negatives attract positives. We also did this with the water, so we call it water magic. So we turned the sink on very small stream of water, rubbed the balloon in our hair, and then we held it towards the stream, and the water started to attract to the balloon. That's because the balloon had more of a negative charge, and the waters, the positive molecules on H2O, which are the hydrogens, were attracted to the negative charged balloon. So they started causing the water to bend. All right, you're going to make static detectors later in today's lesson. That's going to be one of your stations. So let's get started with the notes. What is electrical charge? Electric charge is a property that leads to electromagnetic interactions between the particles that make up matter. So there's electrical charge. Some objects can have a positive charge, and some objects have a negative charge, and there's other objects that have no charge at all. This is similar to our atoms. If you remember all the way back when we talked about atoms. And if an object has no charge, we call it neutral. And here's a video Bill Nye clip. You can click on that or use your QR codes. And there's a girl here with our Van de Graaff. I think we have a Van de Graaff here we're going to use and show. And so let's keep going on with the electrical charge. So all atoms have a dense center, which we call the nucleus. Nice review. There's the nucleus. Nucleus contains two types of particles. We said proton and neutrons. Proton, as you should all know, has a positive charge. Neutron has no charge. The electrons are the third type of particle that has a negative charge, so a charge of -1. So when an atom has the same number of protons and electrons, it's overall no charge. It's a neutral charge. So let's identify the protons and neutrons in this model, just as a quick review. These are the electrons. The positives are the protons, and then these little white particles with no charge are the neutrons. Atoms can lose or gain electrons. So when this happens, the atom has an overall positive or negative charge, and we call that an ion. So if you remember back in November when we talked about ions, we're bringing it back to electricity now. So if it's a positively charged ion, that means they have more protons than electrons. Negatively charged ions have fewer protons and electrons. So the overall charge of an object is the sum of the charges in its atoms. So if there's more electrons, it's more negative. If there's more protons, it's more positive. So what affects the electrical force between two objects? So any two charged objects exerts a force on each other, and it's called an electric force. The electric force acts between objects even when they do not touch. So they don't have to touch, but they can still either attract another object or they can repel another object. So electrical forces that either can pull an object together or push them apart. How strongly that electrical force pushes or pulls depends on the charge of each object and how close they are together. If it's more negative charge and they're both negative, they'll push apart real far. If they're both positive, they'll push apart real far. But if they're opposites, they're going to attract. So opposites attract, like charges repel. And that's what you need to remember. Opposites attract, like charges repel. So if an object has like charges, they repel each other. The object exerts electrical force that pushes them apart. So positive and positive Okay, they're going to go apart. So remember, what affects electrical force between two objects? It's their charge. Okay. So two objects with unlike charges are going to attract each other, okay, and exert a force on the other, pulling the objects together. So here we have, these are like charges, they're pushing apart, but over here, they're coming together. Okay, over here, like charges, like negative charges, they push apart. So the more the object's charge is, or the greater the object's charge, okay, the greater electric force. Okay, and this is true whether the object repels or attracts. So if it's stronger, okay, if it's a stronger positive, they're going to repel more. If it's stronger negatives, they're going to repel more. If there's stronger positives and stronger negatives, and they're coming together, they're going to come together more. The distance between two objects also affects the size of electrical force. Okay, so the closer together the charged objects are, the greater electrical force is. And as the charged objects move farther apart, they attract or repel each other less strongly. Okay, so all that means is if the balloon's closer to your hair, so you're going to feel that pull of your hair to the balloon. If it's farther away, you won't feel as much. It's that whole static electricity thing. Okay. So, what a shock. Okay, so how can objects become charged? They become charged in a few ways, 3 ways. They can, it's only when they gain or they lose electrons. They can't gain or lose protons. They only gain or lose electrons. So 3 ways. It can be done by friction, by direct contact, by touching, or by induction, which means it's getting close. So charging by friction occurs when two objects are rubbed together, causing a transfer of electrons between the objects. So when I rub the balloon with on my hair, I transferred electrons from my hair to the balloon. Okay. The other way is that charged objects can, if a charged object and an unchanged object touch each other, the charged object can transfer some of its charge to the area it touches. This is that direct contact. Okay, so if I actually touch the thing, okay, if I actually touch the water, and then you notice the water went straight down again, the charges went from the balloon back to the water. Induction is another way of rearranging, okay, without touching. That's what you need to know. Induction is how you can charge an object without touching it. So, for example, if objects with a negative charge is brought near another object with a negative charge, the electrons in one object can begin to move away from the other. And here's a quick video on charging by induction I would love you guys to watch in your independent station. What's static electricity? Okay, so static electricity is just the buildup of electrical charge on objects. You guys experience this all the time. If you rub your bottoms against the seats and then you stand up and touch the seat, you're going to feel a little shock because you're doing it by friction, by almost by direct contact, by friction. Okay, and when you're building up a charge on you, and when you touch the metal on your chair, the charge jumps from you to the chair. You do this with your socks, getting out of a car in the wintertime. Those are all static electricity. Okay. So charges that build up as static electricity eventually have to leave the object, and that's when you touch the chair and you heard that snap. Okay. This loss of charge is known as electrical discharge. Okay. Electrical discharge may happen slowly or it can happen quickly. So when it happens in lightning, okay, that's very, very rapid, very quickly. Okay, so it happens very fast. Or it can just happen slowly, just by going from one object to another, kind of slowly touching, maybe through induction, right, that kind of thing. Okay. So your other station you're going to do today is going to be static stations. So you're going to investigate static electricity with several objects around the room. Okay, on your lab sheet, write down your observations and complete the explanation of what happened for each station. So if you haven't done this already, this is going to be one of your stations. There's about 9 or 10 stations, and that's what you'll do today.